So in this session we are going to talk about three things: securing, connecting and scaling. Okay? Now, if you have an application, you need to secure it. And the biggest challenge for a developer is to secure an application. Why? Because he needs to maintain the credentials of the users. He needs to safeguard the authentication mechanisms. He needs to do so many things. So what we have done with Azure is we give you the tools in which you can offset some of this to third parties. And how's that? So we have something called the access control service. Now let me go back here. In the morning I showed you an application called the blob share. When I sign in, I have a signature from Windows Live ID, Microsoft Active Directory, Yahoo, Google, Facebook, Twitter, whatever I want. Right? Now, what this does is, it is offloading the authentication to a third party. So the blob share is not maintaining any authentication mechanism. It says if you trust Live ID and you have a Live ID and Live ID trusts you, and authenticate that you are a valid user and say who you are, then I trust Live ID. Okay? Or if Facebook can guarantee who you are, who you say you are, then I will trust Facebook. We are talking about authorization. We are not talking about authentication. Sorry, we are talking about authentication, not authorization. Right? So you're authenticating the person that he is who he is saying. I'm not logging in with your user ID, putting my password and getting into the system. Right? So with that, let me show you the actual experience. If we go back here into our portal, we have something called Service Bus, Access Control and Caching. If I click on this, I have access control. Now I have to, once I create my namespace, I can go to Access Control Service and it will take me to the Access Control portal. In here I can choose the identity providers that I am going to rely on, right? So by default you have Windows Live ID. You can add Google, Yahoo. So if I come and say add, I can add Google and Yahoo by default. Okay, let me delete these and I'll show you the experience. So if I say add, I can click Google, click next, right? And if I say save, I am done. Same goes with Yahoo. But with the other providers, I need to put in more information. Like for example, if I go to Facebook, it's a little more work for me. Like I have to give it the application ID, the application secret, because this is how Facebook works, right? So I am providing the details that integration identity provider is requesting from me. Same thing I can do with Active Directory services. I can authenticate against Twitter. I can add my own, right? So let's go back. Let's take Google. Next. And save. Then again I add one more, Yahoo. So once I have my identity providers listed, that these are the identity providers I'm going to work with, I can go and set up a relying party application. Now what's a relying party application? It is the application that I am developing. My application is relying on an identity provider, right? So in our case, if you see BlobShare is the relying party. It relies on these identity providers, right? It relies on these identity providers to provide authentication.
So you don't have to manage this part completely within your application?
I don't have to manage this part completely. So let me delete this because this is something I had created earlier. So now I can add a relying party. Gentlemen, hello. So I give it a name of my relying party. I give it an identifier. I give it a URI. So I can just basically say blobshare.dpe.ms. And if you see here, it says which token format do you want to use for the access control services. So these are standardized token formats, and we'll talk about what token formats are in a while, right? And then I can say now I set up my identity providers that I have. Per application, I can choose which identity providers that I want to use. So if I come in here, I say I don't want to use Windows Live ID, I just want to use Google and Yahoo. So I'm going to be presented with Google and Yahoo only. Or I say I want Google and Windows Live, I don't want Yahoo. I'll be given Google and Windows Live, no Yahoo. Or I can choose all the three. Great, right? Click Save. So now I have my relying party application set up. If I go to rule groups, okay, let's delete these two. No, I want to delete that. I want to delete this. I can add a new rule group at any time here. So now I have the rules that I need to define for the application. And what is this? So if I come here, let's delete this. So if I come and say add, okay, then I'm saying my identity provider is Google, and when an input claim comes for a name, right? So if Google is presenting name to me, then how do I receive the name? I receive it as, let's say, name. So keep in mind now what you are doing. You have a standard token, a standard format that you understand. You are mapping each provider to that one format so that whichever provider is going to send you the data, you understand a single format, right? So you understand a single token. The access control service is going to go to the identity provider, authenticate, map these credentials to your token and present you the token. Clear? I could do these manually, or I can come back here and say generate. So I can choose the providers that I want, click generate, and it will generate all the mappings for me. Clear? then you set up the rules for your own provider. So you are going to give a format, and then you map to what format you want, like you did here. Okay? Because see, underlying this is the Windows Identity Foundation. And you can set up easily using the Windows Identity Foundation, your own provider. Yeah.
Why there is a name and an email address at the same time, from Google, for example?
Name is the name that you're providing from Google, and email address from Google. These are the fields that Google is giving you. When you authenticate using Google, Google is going to send you the email address of the person, his name, and his identifier. Live ID only gives you identifier. It doesn't give you the email address and name.
Why?
That's how Live ID is set up. Now don't ask me why. This is how they authenticate you. This is what they give you in return. Okay. Yahoo, on the other hand, gives you name, identity provider, name, and email address. So it depends upon each provider what they are going to give you.
I didn't get the word when you were talking about the tokens. What I know about tokens is the expression that is going to be generated for you after providing your email and maybe your login name.
It's going to be clear. I'm just going to walk you through and you'll understand. Okay? So this is how you set up the access control service. So let's run quickly through the presentation. So we've seen most of this. As I said, it's standard-based identity providers. You can have enterprise directories like Active Directory Federation Server. You can have web identities like Live ID, Google, Yahoo, Facebook, Twitter. Right? You can have these. So it gives you a single sign-on experience. Now here, pay attention. You have a client, right? Now this could be a web page, it could be your phone, anything. It's going to go and access, the client is going to go and access that application, right? That application now needs to authenticate who you are. It needs to make sure you are who you say you are, right? You could use SQL Server membership provider, set up a login on your database, password on your database, or you can offload all of this to a third party. So that's what we are doing. This is going to be sent back to the client to be redirected to the identity provider he chose. So if I click Live ID, it's going to be redirected to Live ID. If I choose Google, I'm going to be redirected to Google. If I choose Yahoo, I'm going to be redirected to Yahoo. Then I am going to go to the identity providers page, log in, get authenticated. Now the identity provider is providing me a token. What token is this? This is the token of the identity provider. This is not something that I understand.
And not my username or my email. It's something that is ununderstandable.
No, this token does have your email address, not your password.
This is what is generated based upon my email and my...
This is generated based upon your credentials that you gave either to Facebook, to Yahoo, or to Google, or Live ID. So depending upon the identity provider, they are going to send you something back. Okay? One is the authentication, either it succeeded, failed, whatever. So it's going to send you a token in its own format. That token is then redirected to the client. The client takes the token and sends it to access control services. Access control service is going to take that token, validate it, that is a valid token. It's going to run the rules engine. You remember we set up the rules? We did a mapping. It's saying name from Google is name in my case. Email from Google is email in my case. So I have a standard token, and now the access control service is mapping this to my token. Okay? In our case, it is SAML 2.0. Now it issues a new token. This token is sent back to the client. The client takes that token and sends it back to the application. application verifies this as a valid token or not. If it's a valid token, then it is going to give you entry. Okay? And it's going to give you the resource in return. So this is how access control services work. Any questions so far? No? Good? Okay. So as I said, you can integrate it with Windows Identity Foundation and tooling. We have good support in tooling for the Windows Identity Foundation. It's claim-based access control. So you send a claim to an identity provider, get authenticated, and a token is sent back to you. We support most of the common formats. We support most of the token formats also. It's integrated and customizable home realm discovery. What this means that is, instead of having a Facebook page or a Yahoo page or a Google page, you can have your own login pages for that identity provider based on your look and feel or whatever, right? And you can use that and then send the data back to Google, and Google will verify and send it back to you using services. So you don't have to go to Google's website to get authenticated. You can have your own look and feel. Clear? Oh, definitely. But only that you are now capturing the UI.
No, you should go to Google and register there.
Pardon me?
You should go to Google site and register there and come back.
You choose.
Huh?
You choose.
You choose.
Yeah. Okay. Now all of this is based on OData. So you have OData-based management services for access control also. So you have these APIs that run on top of OData. Now let's talk about connecting. Now when you talk about connecting, there are two parts to connecting. One is the service bus, okay, and then we have the Windows Azure Connect. The service bus provides a messaging and connectivity mechanism similar to your, it's loosely coupled, okay. Let me show you before we go anything. So what do I mean? I want to create a channel between my application sitting on premise to the application in the cloud. Now to do that, right, I need to have my firewalls opened, right? I need to have the ports opened. What we are doing with this service is we are creating a transport layer using TCP/IP. Okay? It's an application to application connectivity. So the receiver opens an outbound socket to the service bus and registers a bidirectional socket so that it can receive and send sockets. Fine? The sender, on the other hand, it opens an outbound connection to cloud. And then when it sends the message, the service bus knows how to take your message and route it back to the sender. Clear? Okay. So I have a sender, I have a receiver. If they were sitting in the same box, you would have a straight line. You would just send a message to the receiver. Like for example, if it's a web service, you just call the web service or whatever. Because you're on the same domain, on the same network, you don't have issues with firewall, things like that. But if you're across firewalls, one is sitting in the cloud, one is sitting on premise, what do? In the service bus scenario, the receiver opens an outbound connection to the service bus, right? This is an outbound bidirectional socket, so it can receive and send data. On the other hand, you have the sender, which is opening a outbound one-way connection. So when it sends the data, the service bus knows how to take this data and route it to the subscriber, right? So now you are traversing firewalls without having to open ports. Clear? So you have a reliable decoupled transaction-aware messaging system. Okay, also part of the service bus. So one is the connectivity. We saw how to connect application. The second part is messaging, right? So the messaging, similar to your storage queues, provides a reliable, decoupled transaction-aware messaging system. So if you see here, you have a sender and you have a receiver. Now the sender sends data. The receiver will pick up data at its own leisure. Now if you have a large load, then you can increase the number of receivers. Right? Follow me or no? Okay. And these are all load balanced. So any receiver can come in, pick up the queue at its own leisure, process it, and put the message back. What you can also have is, and somebody asked me for BizTalk, something similar to BizTalk, is you can have a pub-sub kind of a scenario where a subscriber sends in a message based on a particular topic. A receiver subscribes to that topic. Okay? So now it's not going to pick up anything. It's going to only pick up those things which are related to the topic it has subscribed to. Okay? Now if you look at the API model, we have the applications sitting on top and we have the service bus. Now you have either a direct connectivity using HTTP REST. So if you have open ports, right, you can use HTTP and you can use WS services, or you can use the messaging API that has been provided to traverse the firewalls and create that secure kind of a connection. Now let's talk about Windows Azure Connect. Now Windows Azure Connect is again a mechanism to connect over firewalls, but this works at the networking layer. So it creates an IPsec across firewalls and allows you to connect your on-premise servers to the cloud. Now I told you you could have Active Directory Federation services. Now for example, you want to do authentication against a domain. How will you do that? You create a Windows Azure Connect, right? So now the application in the cloud sees your domain as part of a single entity. Get me? So your application now is like as if it's domain joined. So it can do authentication based on that domain. Or if you have an on-premise SQL Server database and you have applications sitting in the cloud, you want to get data from the on-premise SQL Server database, you can use the Windows Azure Connect. Okay? So let me show you. So if you come back to our management studio, sure. We are nearly done with this if you want. We are nearly done. There's hardly anything left. So if maybe we need, okay, let's go pray and come. But let's make it quick. You want to go and pray? Huh? So in the management portal, let's log into our Windows Azure again, www.windowsazure.
the Windows Azure is there is a local installation in your client to test your application? There is no.
Yeah, there is the one I showed you in Visual Studio.
Yeah.
That's it.
Yeah. It's called Visual Studio Azure. Or it's called?
No, it's called the Windows Azure SDK for Windows Azure SDK.
That means I can play with it.
Yes.
And not subscribe for the.
Yes.
For the.
Yeah.
Website.
But there are certain things that you cannot play with, like for example, service bus. You don't have a locally. Service bus has to be deployed.
But if I want to build an application.
Yeah, if you want to build an application, you can use the compute. You can use what do you call the storage emulator, so tables, queues, all that you can use. You cannot use a service bus. The service bus has to be hosted. Okay, so if I come in here into the storage accounts, sorry, no, here in the access control and caching. So in the service bus, I have access control, service bus, and caching. Also down here, so this is where you will set up your service bus, right? We talked about. Now you also have something called the virtual network. So in the virtual network, you have something called the get activation token. Okay, if I click on this, it gives me this activation token. I'll say copy token to clipboard. Okay, and if I go back to Visual Studio, I had this application here. If I say properties, not here. There's an option here, signing, settings, response. I don't seem to remember, in which you basically provide this key. Okay, so this key then allows your application in the cloud to identify the endpoint on the client. Okay, so as I told you, you have an IPsec that has been created, and for that I'll come back to this again. Somewhere here. Yeah, it's on the roll. So you have virtual network. So you activate the Windows Azure Connect, and in here you paste the key. Okay. So now when you're going to deploy this configuration, right, the Azure server knows how to connect to the client, right? So this is one part of it, and this is not that part. Okay, leave this alone. And then the second part is to install an endpoint. So if I click on this, I can copy this to clipboard, click OK, and this I am going to deploy onto the machine that I need to connect to. Okay. So for example, if it's going to be my SQL Server database, I'm going to click on this, and it's going to install an executable for me. This executable is going to run as a service on my machine. Okay. And this is a service that is going to connect to Windows Azure and create that IPsec tunnel for me. Now, you have this service running. You deploy that code on your Azure application. Now, your application knows how to connect to this endpoint. So, if you go here, back to the portal, if you clear the groups, you will be able to see here, you see edit group, edit role, connections, endpoints. All those will be available to you once you start deploying these. So once you deploy your application and you deploy your service, you will be able to see the activated endpoints in here. Okay, so this is how you create that Windows Azure Connect connection. Now let's talk about scaling. Now if you want to scale, there are two things that you need to keep in mind. One is caching, and the second is traffic manager. Now what caching allows you to do is it allows you to cache data. Now we saw about the CDN, right? The CDN allows us to cache what? Objects. It does not allow us to cache data. The Azure caching service allows us to cache data. Thanks a lot. It allows us to cache in-memory data, because if you see this diagram here, retrieval from disk is slow. It's the slowest. Right? So if I have to go to my SQL Server database and I have to retrieve data, customer data, product data, it's going to take a lot of time. If I have to do it over the network, it's faster, but still time consuming. But I have to do it from memory, it's the fastest. So this is what SQL Azure Connect does. It allows you to take the data and host it in a cache. So you have two caches. You have the local cache sitting on machine, right? And you have a cache which is the Windows Azure App Fabric cache. So whenever you want to retrieve data, it brings it from the Azure cache and caches it locally also. Clear? Let me show you an application. So let's run Visual Studio. Okay. So here what I am doing is I have an application, okay, and this is a standard application. This is not an Azure application. It's an ASP.NET application. What I'm doing is I'm creating a data cache factory, right? Now, how do you get this data cache factory? What you can do is, how many of you have used NuGet? NuGet. NuGet is an package installation utility. So if you go to the web and say www.nuget.com, NUGET, NuGet. It downloads a Visual Studio extension. Okay, it's nuget.coreplex.com. Sorry, that's a different NuGet. So you can install NuGet from here. I think it's also org. There's an org also. So you can install NuGet from here. Okay. And what that does is, if you go back to Visual Studio and right click on your solution, it says manage NuGet packages. So in here, the references. The one I installed here, I don't remember right now. I think it was Azure caching. But you can look up the documentation and it'll give you. So if you install the NuGet package for Windows Azure caching, it does a couple of things. Number one, it installs the references. It downloads the DLLs and installs the references. And most importantly, it sets up your web config, right, with these two entries. You have got the data cache client default and SSL endpoint. Now, default is port 80 and SSL, as you know, is the secure port. Now, what you need to do is, if you come back to our portal, okay, I have too many versions running. Yeah. So if you come back to here, access control and caching, I have a caching service, right? And have a namespace. You see the service URL? This is what I need. And this is the service port. So I take this information and put it in Visual Studio. So here I have my service URL and this is the port. Then also I need the authorization info, which also I get from here. You see the authentication token? Clear? I can copy this and paste it into Visual Studio. Once I have that, right, I have the DLL set up, I have the namespaces set up. Then I can start using the cache. So I create a cache factory. From the cache factory, I get the default cache. And then I'm going to check if this cache is not existing, right? Then I am going to create a new cache. So in our case, it's going to be Riyadh. Since I ran this, this probably might already be there. Azure ACamp. Okay. So if I set a breakpoint here, I run this. Now this is just for the sake of demo. You usually would not create an ASP.NET application and use an Azure cache, because just to retrieve the data over the network is going to be too costly, right? What happened?
For how long the data stays with the cache?
How long? You can set the expiry time. So if you come in here, I don't know what's going wrong here. Something is wrong here. Anyway, because this was working last when I demoed it. So if you come in here and you say add, you can specify a timeout period. Okay? So you tell exactly how long you want to keep that cache alive. I don't know what the default value is, but then you can definitely put a timeout.
But it doesn't give me a sliding expiration.
Sliding expiration would not be in this context. Sliding expiration would be on page retrievers. Would that? Here you are actually going and retrieving the data. I don't know if there's a, I haven't checked the API if you can extend the timeout or not. I can check.
Any other overloads for this method?
Yeah, there are plenty of overloads. Like you can put tags, region, several overloads are available. But I can check and I can come back to you, okay? So this is caching. So now you have ASP.NET providers for session state and page output caching. Okay. Now, as I told you, when you are working with Azure, you do not have the concept of an in-memory cache. There is nothing local, because that machine can be shut down at any time and a new instance can be created. So if you are going to store session state on a machine and you go to another machine, then the session state is going to get lost. So session state has to be is an external provider, right? So now you have a service which gives you the caching services. Clear? So this is standard. Now let's talk about the traffic manager. Now, as I told you earlier, if I have my application deployed in the North American data center, and if I start using it in the States, I have a certain latency. If I start moving out, right, I get a high latency. As I keep moving out, the latency increases, right? So if I'm coming from all over from Southeast Asia to my North American data center, I'm going to have a huge latency. Now to avoid that, what you can do is have your application in multiple data centers, right? But then how do you manage moving between these data centers? Who decides which data center do you go to? And that is the job of the traffic manager. What traffic manager does is it monitors the incoming request based on the DNS. It's going to identify which data center it is going to redirect to. So if I'm coming from Southeast Asia, it's going to redirect me to the Southeast Asia data center. If I'm coming from America, it's going to take me to the American data center. If I'm coming from Asia or Middle East, it's going to take me to the European data centers. What happens if one of these data centers goes down? Then you will be redirected to the closest data center. If one of these data centers becomes heavily bogged down because of huge traffic and it is not able to request you, you will be redirected to the next data center. So it's managing the traffic for you, and that's the job of the traffic manager. Clear?
The traffic manager is a software.
It's a service. So let's, I will show you. Nothing much here. So if you go back to our portal, because it's still in CTP, so if you go here, if you look at the beta programs, okay, so from here you can request access to the traffic manager and the virtual manager, virtual machine roles. So if you remember in the morning, I said that you can host a complete VM by itself, right? So these two programs are still in beta. They're not available as full release options. I don't know why this is not coming out. Yeah. So if you see here, you have the virtual you have the traffic manager. Okay. Yeah, it's in here. So once you have access to that, you will be able to manage the traffic from here. Now what you do is you can set it up either for performance. Okay, you can set it up for failover, or you can set it up as round robin. So in the case of failover, you decide if the first data center goes down, then which data center are you going to redirect to? If that goes down, then which data center you are going to redirect to? You provide the configuration. In terms of performance, as I said, it's going to identify the closest proximity to you, to the data center, and redirect you to the based upon your incoming, based upon your proximity to the data center, the health of the data center. For example, if it's not there, the data center link has crashed, then it's going to take you to the closest data center. So the traffic manager is going to decide. A lot of variables will play. And then you have round robin. You can just go one after the other. So you decide. Okay. This is important because you would not go across data centers, but in the same data center you can have multiple roles. and you can move your traffic from one role to the other in a round-robin fashion. Okay?
So it doesn't only manage the traffic across the data centers, but it also manages the traffic
Within the data center also, yeah. Okay? So that is all for the traffic manager. Now, quickly before we close, some of the scenarios that you would want to take your application. As I said, not all applications are suited for Azure as of today. Performance intensive, high transaction applications are not the best bet to take to Windows Azure. So you have websites, right? Process intensive tasks like, for example, Pixar. You know, the company which makes these animated movies. Pardon me? Not Steve Jobs.
What was the question?
Pixar. P-I-X-A-R. Yeah, the companies which make these animated movies, DreamWorks, these, they spend a lot of time, okay, and a lot of money on the, they spend a lot of money on hardware, right? So to build a movie, they have to go and buy these huge servers to process these videos. The rendering of these animations takes a lot of processing power. Now, with this compute infrastructure available, they can just rent the infrastructure, process the images. They have no upfront cost. They don't have to buy servers. They don't have to buy machines. So the cost of producing these movies comes down considerably.
Yeah, like 10%.
Yes. You have, for example, you are doing 3D modeling. You want to process your images. You want to process your models. Where do you do that? You can do it on the compute instance. You have an application which has a lot of computation for scientific data. Be it, you can put it there. You have applications which connect to devices. Azure is a very good platform. Why? Because we give you the connectivity to all the platforms. Right? So we have SDKs for phone, we have SDKs for iOS, we have SDKs for Android, we have SDK for Windows 8. Now you design a service once and it is used across the platform. I can do an access control service from a Windows phone, from my iOS, from my Android. It's the same thing. I have a single source of data storage. So my backend application remains the same. My front end I can design for whichever device I like. Okay? Games. We have a complete toolkit for games. If you go and look up Windows Azure for social games, you will see that a lot of work has been done to help gamers develop games easily. Okay? So for example, you are playing a game, I am playing the same game with you. There needs to be a central mechanism where we share information, right? You make a move, I need to be notified of the move. So there's a messaging going back and forth. Your data needs to be stored somewhere. I need to be informed of that data. So if you make a move, that move gets saved. I get notified, I update my move, it goes back and it gets saved. So that whole service has been made for you. So creating games is much easier. So there are various scenarios that are already available on the Azure platform. Developing on the platform has become very much less painful than what it used to be. Okay? Many of these tools are there. So I suggest you go to windowsazure.com. There are different sections that are there depending upon if you're a PHP developer or a Java developer or a .NET developer. Go through it. You have a lot of how-to-dos, documentation, sample code. The tools are there. You can look at the tools and see how they help you, right? So any questions before we wrap up? No? Yeah?
If I make an app,
Yes.
do I have to make another to like for Windows Phone? It's the app is for the PC or desktop. I make another design for the Windows Phone or iOS or?
See, that's what I said. Your application is the front end, right? So you're going to have a different front end for each device. But the back end processing is going to remain the same. That's not going to change. You're going to store in the same place. You're going to use the same processing.
But the interfaces change.
The interface will change. But the interface is a very negligible part of your application. Right?
Right.
Where do you put majority of your work? On your business logic, on your background. The UI is just a shell. So definitely you will have, there are ways to circumvent that also. You can write it in HTML5 and then have it rendered on all the browsers or on the devices. But if you want a native look and feel, then you'll have to develop for the different platforms. But here Azure helps you, right? Because the SDKs allow you to write the code for each platform. So for example, if you're writing an access control service, it's available to you from all the devices. The storage APIs are available from each device. You don't have to learn something new. It's the same concepts. Okay? Anything else? Yes?
For example, regarding the storage, for example, I have a small application like library. I want to give it to someone.
Yes.
But he doesn't have what's called SQL Server. He doesn't have anything. Just I want to program this library by SQL Azure.
Yes.
And let him store the data on the data center.
Yes.
I mean, just for free. Why not I pay monthly issue basis?
Why will you not pay?
Huh?
Why will you not pay?
Because it is small application. It's not,
Okay.
It's not custom.
Can I ask you a question if you don't mind? Where do you work?
In King Faisal Specialist.
Hospital. Okay. Now, if you are a hospital, a private hospital, and if somebody came for treatment, would you give it to them free?
Yeah, not, I mean,
It's all at the end.
No, it is not. This is not my question. My question is why we make it like, for example, Hotmail, for example, Google.
These are
they give you.
Nobody gives anything free. There is no free lunch in this world. Nobody gives you anything free, my friend. Huh? Nobody gives you anything free. Let me complete. Okay? If they make money somewhere else.
They use advertisement to make money.
They make advertisements. A major revenue of.
Okay, why they didn't make?
You do the same thing.
Advertisement.
That's what I'm saying. We are not software as a service. Okay? We are providing you platform as a service so that you can develop your application as a software as a service. Now, if you decide to create a library, you create a library and put it free of cost and make the money on the advertisement and pay for the Azure storage. People are doing that. People are doing that.
Not monthly basis, I mean.
You pay 6 months. You pay annually.
What my question is, maybe they buy a library program, for example, 200 riyal.
That's not the model.
With it.
That's not the model. That's not the model. The model is more subscription based. Okay? Like for example, if you go and take an exchange subscription, do you pay them one-time fee? No. You pay them monthly. If I am going to go and for example, I have an email account, personal email account, I'm paying monthly. Now they're not going to give it to me free of cost. So it's, at the end, it's all. These data centers cost billions of dollars, billions. So they have to get the revenue from somewhere. They're not going to give it free of cost.
I mean just for portion, just not that for the whole people, just for portion. For example, the Windows, for the Windows application.
Yes.
It is free for students.
Yeah, we are giving that.
Yeah.
We are giving that.
Why?
We are giving that because we want students. That's a different. See, there is something which is cost. Okay. See, as I said, there is something which is cost. Now, somebody who has to pay for that. Now, when you talk about Windows, some organization within Microsoft is paying the money for that. Because they are giving it to you free, they are bearing the cost of that. Visual Studio, you know how much Microsoft makes out of Visual Studio? 90% of it gives away free. Yeah, but then even Azure, we are giving you 3 months trial accounts. We are giving, for example, professional developers 750 hours free of cost. There's no charge to that.
But you should have.
But what you are trying to do is develop an application. Now you do it for free, you pay. You as an individual have to decide. Now Microsoft decides to create a service and run it free of cost, that's their business. But if they were going to give it to somebody else, they're going to charge.
At the beginning, it was for free.
Yes.
And it stayed for free for a while until the people became familiar with the technology, and then Microsoft started to charge people.
Yeah. See, it's at the end a business model, right? We have to be paid salaries.
They can make money, for example, by one shot. For example. If you add a new company or you add a new person, please give us 100 riyal.
But they're not in the business of doing library management systems. That's not their job. That's not their business. Why will they go into it? They are providing you the platform. You as a person, you can become an entrepreneur. You come up with an idea. Okay, Facebook, free of cost, making billions. From where? Advertisements. By selling your information.
Right.
Yeah. So at the end of the day, it's all dollars. Nothing is free. Anything else? Thank you very much. I hope you all enjoyed it. If you have any questions, then please feel free. You can reach me at any time. You can reach me at Twitter at FawzanK. That's my Twitter alias. Can I write it? So you can reach me on Twitter at FawzanK, or you can send us an email at azure@microsoft.com.
It's too small.
It's too small? Okay, let's do this. No. Is that okay? So the first one is my Twitter. Second is our Azure email alias. There are a lot of videos available on the net. You go to channel 9, there's a huge number of videos there. On Azure. Go to Mix, huge number of videos. Okay? Thank you very much.